This video is going to deal with what we call the Suvat equations. And we're going to derive an equation in this one using some pretty simple techniques that involve a velocity graph. But before we can get to that, we actually have to define kind of what this Suvat variable system means. It's not anything that's difficult. It's just that IB gives it a name that usually we'll refer to as the motion equations or the kinematic equations. So we got to define our variables just to make sure we know what we're working with. So the first one is S. That is going to be displacement. And that typically is measured in meters. However, it could be in any units depending on what you're measuring with. As long as your units are consistent, any unit works there. U is our first new variable. That is what we would call the initial velocity. That is measured in meters per second, but IB prefers us to write it as meters times second to the negative 1. I like meters per second. It tells me that for every second, my displacement will change by this many meters. This doesn't bother me if you want to use this, or if you want to start with this and slowly work your way into that, because this is the way that they'll expect you to do your exams. That's fine too. V is what we would call the final velocity. Also measured in meters per second. A is acceleration, measured in meters per second, also known as a meter per second squared. IB again would like you to write that as meters times second to the negative 2. And finally then T is just time, and that is measured in seconds. So that's what our variables stand for and the units that they are going to be measured in typically when we're using the SI system. Now we want to derive our first equation. And to do that, we're just going to take a real simple graph of an object that's moving at an increasing velocity. You can see we have a velocity on the y-axis here that's going to be measured in meters per second. And this is our time, which will be measured in seconds also. And what we first want to do is just kind of look at this in terms of its slope. You know that it's not starting from 0, 0, which indicates it has some velocity other than 0. Well, we just got done defining that is our u velocity, and it ends up going a final velocity that we would call v. So you can see that this slope of this is kind of how our velocity is changing. And we know that changing slope indicates acceleration from something we've done in the past when we were doing our motion graphs. But for now, we're just going to kind of look at these two things and say, okay, well, if I wanted to find out the slope of this, I would usually just take the rise and divide it by the run. Well, the rise is going to be v minus u, and the run is going to be t, whatever time t is, minus 0. And from a dimensional analysis standpoint, what the units are for these things is going to be meters per second divided by second. And we hopefully recognize that that's acceleration. So I can now set my slope equal to the acceleration and say, okay, here's an equation. A equals v minus u all over t, or to write this the way it's traditionally written, it will be v is equal to u plus a times t. And that's the first of our motion or Suvat equations.